Alright, so in this question, let's make believe that you are asked to find, this is a Norton circuit setup. So let's make believe that you're asked to find the currents in the Norton's resistor. So if I'm to find the current in the Norton resistor, that is the current here, let's say this question asks, you ask find the current in 0.9 ohm resistor. So to find it, all I need to do is to ask myself, how many resistors do I have here? 2. Are they in series or parallel? They are in parallel. So whenever they are in parallel, assuming it's in series, you just add. But if they're in parallel, all you need to do is to say the current entering the first resistor plus the current entering the second resistor will be equals to the total current. This is Kirchhoff's principle. And if that is the truth, you now need to remember that current from Ohm's law is equals to what? Which is in the current section. So let me help you. So Ohm stated that the work done in moving a unit charge through a metallic conductor is directly proportional to the output, and the output is the current. Remember that current is charge for any given time. So charge per unit time is current. So if I know that, I'll simply say that this I1 will be equals to V is always the same. Voltage is the same for anything in parallel, while current is the same for anything in series. V over R1 plus V over R2 will be equals to the total current. Then remember what we just stated. We just stated that V is equals to IR and V is equal, I is equals to V over R. Note that. So if I know this, it simply means that I1 is this and is equals to this, and I2 is equals to V over R2. That is what we are trying to do. So if I've noted this, let's solve this. Let's solve this total current that is here. Solving this, finalizing this is simply the same thing as saying the LCM is R1, R2. If it goes here, you have R2 into V. Then plus R1, everything here go into this R2, R1 into V, because this R1, R2 divided by R2 is R1 times V, so equals to IT. Now notice that this is going to, let me continue this here. This is going to be, remember we already know this, this is going to be the same thing as saying V into R2 plus R1 all over R1 R2 equals to IT. So because V times this is this, V times this is this. So now let's say we make V subject of the formula. Since we now know that total current can be gotten, total current, if it's the total current can be gotten by doing voltage times R2 plus R1 all over R1 R2. This is a formula to note. If they are asking you total current, the total current inside these two things now, the total current inside these two now can simply be gotten by doing voltage times R2 plus R1 all over R1 R2. But if I am asked, like the question said, find the current in Norton's resistor, that is where I need to remember that I can call this one current 1, call this one current 2. Know that. So if that be the case, I will now say, okay, let's make V subject of the formula, because I1 is having V over R1. So that means that this will be the same thing as saying IT, this crossing over, times R1 R2 all over R2 plus R1 equals to V. So I tried making such a formula. This one will come here, then divide by the coefficient of V. This is V. So now come to I1. To find current in I1, I'll just say I1 is equals to V over R1. So substitute for V. Where I see V, substitute this for V. So I'll now have IT R1 R2 all over R2 plus R1, then divided by, remember that everything here is for the voltage and it's being divided by R1, and you remember that if you divide by R1 is over 1. So, and you can remember from mathematics knowledge, if this is so, this is the same thing as saying times 1 over R1, so that this can cancel this, so that the I1 will be equals to total current. So, and we already have the total current in this equation, which is IN. Total current, so which is the same thing as saying now R2 all over R2 plus R1. So if you don't want to stress yourself doing this, solving all this thing, because we can do it for R2. If you don't want to do it, all you can just do to note, or you can just simply note that it will always be the total current. If I want to find for what is here, the the second one, it's always be the total current all over the opposite currents, then all over combination of the two. So if I want to find for RL now, it will be the opposite current, which is Rn, then all over Rn plus RL. So, but if we don't want to do it like that, if we want to go on to solve, if taking note of this one, let's solve for I2. So if you check for this I1 now that we did, it's simply the opposites that is up all over the two of them times the total. So for I2 now, it will be the same thing as saying, put everything for V, R1, R2, then times IT all over R1 plus R2. Yes, R1 plus R2. The setup doesn't matter. Addition. So for everything V. Now, divided by R2. Remember it's I2 we are doing substitute. And this is over 1. And everything division is the same thing as saying times 1 over R2. This will take care of this. So that I'm having I2 equals to R over R1 plus R2, then times IT. So, and remember that what is up here is R1. So, whichever way, so if you are bringing it here, you call this one first R and this one second R, it will just reflect on this one. So, instead of doing this, now that you've noted how we derive the formula, the shortcut is just to maintain what I've told you. Just do the opposite resistor. If you are finding resistor that is the second one, do the opposite resistor times the total current all over the addition of the whole resistor. So I will simply say, if I'm to find the current in Rn in this one, I will just do the opposite, the total current, which is In, then times the opposite resistor all over the sum of the two, Rn plus RL. So it will be the same thing as saying 2. To the same thing as saying 2, RL is 0.1 all over 0.9 plus 0.1. So the current in Rn, that is here, will simply be the same thing as saying 2 times 0.1, 0.2 all over 0.9 plus 0.1, 1. So current in Rn will simply be equals to 0.2 amps. So 0.2 amps. So if I want to find the current in this one, hope you are still recording.
Yeah, man.
So if I want to find the current in this particular one, all I need to, yes, okay, yes, should be, so we'll go for Rn. So for this, it's simply going to be the current in RL will simply be the opposite, which is In times RL. That is the total current times the opposite resistor, then divided by the addition of the resistors. So Rn plus RL. So This is going to be current in RLO, that is load resistor. Load resistor. That is what this LO means. Norton resistor, load resistor. So equals to 2 times the opposite is 0.9 all over. You know the addition, we got the addition of the 2 to the 1. So this is going to be equals to 2 times 0.9, 1.8. 1.8. So as the current. So the 1.8 is in ampere. 1.8 in ampere. So that is the current here. And this is descending as approximately 2 amps. 2 amps. 2 amps. Yes. Is it not? Yes, and if you remember, that time we short-circuited, we got current that is going to that load. That is that the load that we short-circuited that time was 0.1, and then we used it to find IN. So you see, we're getting the same current here. So that is how to find current in any of the resistor. Thank you. Bye. Subscribe to the channel. So I think in our next class, what we are going to be doing is Thevenin, but we'll take more complex examples on nodal analysis, so that for your practicals it will be easy for you to dissect any question that looks like this.